Okay, for today's session we're looking at describing number sets. Now there's two ways of doing that. One of them is called set notation. So we'll look at set notation for the moment. So they're the main things, of course. Other than that, we can describe or we can list the set. So let's have a look for an example. I've got the set of numbers called set A, and so I've got a set of numbers, say 1, 2, 3, 4, 5, 6 and 7. For example, that's the set of numbers. So in set notation, I need to somehow describe what that set is. So for set notation, we have some curly brackets, and the curly brackets represents a set. So it's a set of something. What is it? It's a set of X. I should have called it A, so let's get rid of that. So it's the set of A. And what is the set of A? Well, it's a set of A such that A, what sort of numbers are they? Well, these particular numbers here are whole numbers. So A is an element of the whole numbers, so Z, our integers, but there's more information as well. It's not all the integers, it's only some integers, and those integers are between 1 and 5. So, and then we'll close our bracket off. So the way we read this is the set of A such that, and I'll point out, so the set of A such that A is an element of integers where -1 is less than or equal to A, which is less than or equal to 5. That's the way we would write that in set notation. So that one there is a little bit sort of complicated, but nonetheless you can still write it in that particular way. You can have all sorts of other sets, of course. Set of X, more simple ones, less than or equal to 3. Okay, so in this case, X could be any real number. We don't need to write the real number. Okay, so then we might look at where we might exclude an individual number. So we might have something like this: X such that X is less than 2, except for 1. Okay, so then that would have any numbers that are less than 2, any real number less than 2, but excluding 1, of course. We can draw these things on number lines. So this particular number line, if we look at it, so there's X, say 0 is here, 2, 4, minus 2 and so on. And if we're going to draw that on a number line, so X is less than 2. Now if it's less than, we'll use an open circle at 2. And so it would be down there that way. However, what I haven't taken into account is that 1, which is here, is not included. So I need to have another circle. So let's get rid of that arrow. There we go. I need another circle here at 1. The size of the circles is irrelevant. So there, this time, so X is less than 2, excluding 1 as well. Looks like that on a number line. Okay, so then that's the first, or way that we can look at that, so let's clear all of that. And so now let's look at interval notation. So interval notation is the other way. So there's two different ways that we can list numbers, sets of numbers. Interval notation, we do it like this. So that kind of looks a little bit like a coordinate, but it's not a coordinate. The curved brackets mean something, so 2 and 10. You can have square brackets around, or you could have a combination of square and curly brackets. So the curved brackets means that that number itself is not included, everything up to, but not including. The square brackets, that number is included. So if we look at some number lines for this, and there we go, there's 0 there, 2, 4, 6, 8, and 10. So first one, 2 is not included, so we have a circle at 2. 10 is not included, we have a circle at 10, everything in between. The second one, 2 is included, so as soon as it's included we have a dot there. 10 is included, so we have a dot there, and everything in between. The third one, and I'll draw it down the bottom, the 2 is not included, so we have the open circle. The 10 is included, and everything in between. Okay. If we have something like, where we're looking at something like this in set notation, x less than or equal to 2, for example, that means everything below 2. So for the interval notation, the 2 on the end, that's okay, but we want everything less than that. Where do we end up? Well, we go towards negative infinities, where we're going towards. Now, the convention is that whenever you're using infinity or negative infinity, they have a curved bracket. The technical thing behind that is that we don't actually know where negative infinity is, so we don't actually know where we're exactly, the spot where we're finishing. Whereas on the other end here with the 2, we do know exactly where we're finishing. We're finishing where 2 is, and we know where that is. Negative infinity, where is it? Who knows? Okay, so that is the way that we do that. Of course, we can do them on number lines, something like x is or equal to negative 2. Of course, we can do that on a number line. So here's our number line, and we can do x is less than 2, less than or equal to 2. It's equals, it's counted in. So we colour in that circle, and anything less than, so it heads off down that way. Alright, so that is the exercise essentially. So set notation and interval notation. Let's have a look at just an example. So write in interval notation. So here's an example. So it's in set notation to start with. Set notation, sometimes called set builder. So we've got 3 is less than x is less, oops, let's go back here a bit. Right, 3 is less than x is less than or equal to 5. Intersection with x, where 4 is less than or equal to x, is less than 7. Okay, so intersection, we're looking at the intersection part, so we're looking at the overlap. So we need to think about where the overlap is. Well, when we're looking at the first set, 3 is our lowest, and here in the next one, 4 is our lowest. So if we're looking at the overlap here, it's going to start at 4. Then when we move to our upper end, we got less than or equal to 5 and less than 7 there. So the lowest end of that is 5. So we're going to interval notation, so we've got to figure out what sort of brackets. Now, is 4 included in both of these sets? Less than or equal, yes, it's included in that. Well, it is between 3 and 5, so yes, it's included. And same with the 5. Let's have a look. 5 less than or equal, so it's included. And in the second set, it's between 4 and 7, so yes, it's included. So that one there simply works like that. Now, there is another way that we could do it. We could simply look at each individual set. So the first set, oops, wrong brackets there, is 3's not included. So we go 3, 5. It's included there. And again, intersection with 4 is included, 7's not. So either of those would work fine. Alright, so that's what you need for exercise 1B. You've got set number 2, question set number 2, you've got them on your sheet.